Hi, so this is our second example of homogeneous equation. So let's try to do this one. Okay, find the solution for the following differential equation. Okay, so first of all, we try to identify the type of equation. I believe that we cannot simply separate the variables easily. So we go to the next one, which is linear. So this is obviously not a linear equation where you cannot rearrange the equation in the form of ay prime plus by equals to c. Okay, so next we try to test whether this one is a homogeneous equation or not by rearrange the equation until we get dy dx on our left. So we have dy dx, for example, here. And then this one is 4xy over 2x squared minus y squared. So just by looking at the degree or the power of this equation, I have this one is 1, so the total is 2. So this one I have 2, this one is also 2. So that I can say that I have a homogeneous equation. Otherwise, please try to test for the homogeneity of this equation. It is better, okay? So now I try to make this equation as dy dx and equate these to fxy, okay? So you can simply test this equation by testing f lambda x lambda y. Is it equals to fxy? If yes, then you see that this equation is homogeneous. But just now we already tested this equation by just simply looking at the power or the degree of this equation. So I proceed to use the substitution that y equals to xv and the first derivative is dy dx equals to x dv dx, okay, plus v, do the product rule, and then I substitute simultaneously both of this information into my differential equation here. Okay, so what I have is x dv dx plus v equals to 4x is 4x, but my y is now xv, okay, over 2x squared minus y squared here is x squared v squared. So that what I have here, okay, all right. So let me do this one, x dv dx plus v on my left, but my right hand side of my equation here I have 4x squared v, this one x squared, this one x squared. When we try to factorize x squared and then cancel out at the denominator and the numerator, so that I can conclude that I have 4v over 2 plus v squared, okay. Alright, so now I try to simplify this equation before I transform it to separable equation. So now I have 4v over 2 plus v squared minus v, so that I have 4v. I try to make the same denominator here by multiplying this denominator to this one, so that I have minus 2v, okay, minus v cubed over 2 plus v squared, okay. So this one is x dv dx. So let's try to simplify the right hand side of the equation. Can we do that? Okay, so let's take a look. So we have negative v cubed, okay, plus 2v, okay, over v squared plus 2. All right, so now we try to separate the variables if we can here. Okay, so I hope that my calculation here is correct. Okay, positive 2v, this one, okay. So what I have here is 1 over x dx, and then this one is dv, so v squared plus 2 over v cubed plus 2v, okay. So that is what we have there. Okay, this one is other negative. All right, so now we want to integrate both sides of the equation since this is already separable equation. The right hand side we have natural log x plus c, so this is okay. But what happened to our left hand side of our equation is we have v squared plus 2 over negative v cubed plus 2v. If this one is positive, so that we can apply the substitution technique, but let's try. Boleh ke? Tak boleh. So now we try to move to partial fraction to solve for this integration, so that we have v squared plus 2 over v, okay, negative v squared plus 2, okay. Alright, so now performing the what we call it as partial fraction, by partial fraction, so that I have this one is a linear, so a over v, plus this one is a quadratic, so bv plus c over negative v squared plus 2. Okay, so I try to cross multiply. I just cross multiply, so I have negative av squared plus 2a. Okay, this one cross multiply and then cross here, so I have plus bv squared plus cv, while my left hand side I have this one. So what I do here is I want to check the same term for v square here, okay. I just want to collect the constant value, okay, the coefficient in front of the v square, sorry. Okay, so for v square I have the left hand side is 1, the coefficient of v square here is 1, while my right hand side I have negative a plus b. Okay, for my v to the power of 1, okay, let's take a look what we have here. So I just have c, okay, but on my left I don't have any v here, so 0 equals to c. Okay, and then I just have a constant here, okay, for v to the power of 0 or constant. My left hand side I have 2, but my right hand side I have 2a. Therefore, from this equation, okay, I can solve this equation simultaneously, but this example is quite easy because c is 0. Okay, so from here I can say that I have a equals to 1. Okay, when a equals to 1 here, so b gonna be 2. Okay, so a equals to 1, b equals to 2, and c equals to 0. Then I substitute back into my partial fraction here. Okay, I really hope that you know how to do the partial fraction here, okay, so that I can say that v square plus 2v negative v square plus 2 is actually a over v plus blah blah blah. This one is equivalent to a equals to 1, so 1 over v, okay, plus b, so you have 2 plus 2v over negative v square plus 2, while your c is gone, 0. Okay, so what I can conclude here is the integration of this one, your left hand side here, your integration of this one is equivalent to integrate of this one by using partial fraction. So integrate 1 over v dv plus 2 integrate v negative v square, okay, plus 2 dv give me natural log v, okay, plus 2. So this one is by using substitution again here. So let u equals to negative v square plus 2, therefore du, okay, du equals to negative 2v dv, but here you have 2v dv, okay, but you don't have negative sign, so that here is you have negative, okay, so this one is no longer plus, so this one is minus natural log negative v square plus 2, okay. Alright, so this is for your left hand side of your equation. So I plug in into our solution previously in here, okay. So I can conclude that I have natural log v minus 2 natural log negative v square plus 2, okay, equals to natural log x plus c. You can simplify the natural log. Okay, so we have natural log, okay, v over, okay, v over, because this one is the properties of logarithm, right? So we have over, so this one too you can bring upward here there, so you have negative v square plus 2, okay, square equals to, or you can simply bring the natural log x to your left, so it becomes negative here, right? Okay, so when you simplify the natural log, so we can delete here equals to c, then since just now is minus natural log x, so this one minus, it becomes, it will be placed on the denominator. So we can simplify taking exponent both sides of the equation, so that I have exponent ln or exponent natural log gone, so we have v x negative v square plus 2 square equals to exponent c is a, okay, a equals to exponent c, so that you can try to re-substitute what is your v. So we have y over x square, because this one is y over x, so bring x to here, so you have negative y over x, and don't forget the square here, okay, plus 2, and then you have square over, and then you have a. So this is your general solution. I hope that my calculation here is okay, okay, without any mistake, so that we have this kind of solution. Okay, so that is the end of homogeneous equation. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.